One type of exponential model that I just don't think we talk about enough is compound interest. So we're going to practice here with interest and specifically different types of compound interest. So I cannot hit the next button. There we go. Let's consider a $1,500 deposit earning 3.5% interest compounded annually. What will the balance be at the end of 10 years? First, let's think through the formula. So we have the amount at the end. Actually, let's use A. The amount at the end equals the initial amount. How much are we putting in? We call that the principal. So we put in 1,500. Then inside, I have 1 plus the interest rate, 0.035, divided by how many times am I compounding per year? We're compounding annually, so that's just a 1. And then we raise that to the number of years, in this case 10, times the number of times I'm compounding, which is just 1. So for an annual compounding, it's pretty easy, right? I can rewrite this as A equals 1,500 times 1.035 raised to the 10th power. Because anything divided by 1 is just that number. So I have 1 plus 0.035, and 10 times 1 is just 10. So when I plug that in to my calculator, I end up with a value of $2,115.90. Great. That's the balance after the first year. Now, how much of that, after year 10, please excuse me. How much of that is interest? Well, if I end with $2,115.90 and I only put in 1,500, the difference between that is interest. So I've earned $615.90 in interest. All right, let's do the same thing for 20 years. So y equals 1,500, 1.035, raise that to the 20th power. Your calculator should spit out $2,984.68. Remember, exponents are done first. So if you can't type this all in at the same time, make sure that you do the exponents first. So how much interest is that? Well, again, subtract the 1,500 you started with, and that leaves $1,484.68. So you've almost doubled your money in 20 years by just letting it sit there. One more with 30 years. So again, same formula, 1.035, we're just changing the exponent to 30, which yields $4,210.19. To find the interest, again, we subtract whatever we started with, and after 30 years, you've earned $2,710.19 in interest. All right, moving on to number 2. Joey gets an offer from a bank that's paying 6% on CDs. CD means certificate of deposit. It's you put it in for a specific amount of time. So it's basically you lock money in for like 2 years, 10 years, whatever, and then you pay a penalty if you take it out before then. So that's kind of the idea of a CD. It kind of guarantees the bank that they're going to have your money for a certain amount of time. And we are compounding interest daily. If Joey invests $2,000, how much will it be worth in 5 years? Okay, so let's look at our formula here. We've got y equals the initial amount of $2,000. 1 plus, what's my interest rate? 0.06 over 365. Because if we're compounding daily, there are 365 days in a year. So that's what we're going to divide by. Then I'm going to take my 365 and multiply by how many years? So in this case, I multiply by 5. If you are putting this all in your calculator at one time, it's going to look like y equals 2,000, parenthesis, 1 plus 0.06 divided by 365, parenthesis, exponent, parenthesis, 365 times 5. That will give you the correct answer if you're typing it all in at one point. You have to make sure that your exponent is in parentheses. That is crucial. Otherwise, you do the exponent first, then you do what's inside, then you apply the exponent, right? There's pieces to that. So for 5 years, you should have $2,699.65. So you've earned almost $700 in interest. Moving on to the letter B. 18 months. Y'all, how many years is 18 months? Because this exponent part here is the number of years. So 18 months is the same as 1.5 years. And that's your first step there. So then I say, okay, I've got y equals 2001 plus 0.06 over 365 raised to the 365 times 1.5. Again, if you're typing this into your calculator, 2000 parentheses 1 plus 0.06 divided by 365 end parenthesis. Use your caret for exponent, parenthesis, 365 times 1.5, end parenthesis. And that will give you 18 months. Where's my answer? $2,188.33. So even in just a year and a half, you've earned almost $200 in interest. How long will it take for that to double? Well, if I started with 2,000, doubling, that means I want my ending amount to be 4,000. We know when the time is 5, we're at 26.99.65. So we need something bigger than 5. Well, what about 8? So you got your same formula in case you have forgotten. 2001 plus 0.06 divided by 365, 365 times 8. That yields 3,232. It's too small. I try 10. Substitute 10 in for the year, and I get 3,644. It's too small. I go up by 2, I'm going 12. 4,108. Okay. So that's higher than 4,000. What does 11 give me if I go back down by 1? 38.69. So it's somewhere between 11 and 12 years, but to be over 40, I need 12 years, over 4,000. Okay, so over 12, just 12 years to get over the 4,000 so I can officially double my money. All right, let's just do one more quick one here. A certificate of deposit requires a minimum deposit of 10 grand. Some of them do. The more you deposit into a CD, the higher the interest rate generally. And you must invest for at least 5 years. Also potential. The longer they can keep your money, the higher the interest rate as well. So the CD pays a 2.5% annual interest yield compounding monthly. How much will you be able to cash the CD out for in 5 years? So let's go ahead and plug this in. Y equals, our initial amount is 10 grand. 1 plus, we have a 2.5%. So that's 0.25 as a decimal over 12. Because this is monthly. Raise that to the 12 times how many years? 5. So 12 times 5. Putting that in my calculator, I would type in 10,000 parentheses 1 plus 0.025 divided by 12 end parenthesis, caret to show exponent, parenthesis 12 times 5 end parenthesis. Some of you will have to use an actual caret button. Some of you might have a button that like automatically jumps it up to the exponent. Awesome. I love this for all of you. After you type that in, you will end up with $11,330 and a penny. So after 5 years, you will have earned over $1,300 in interest on that particular account. Hope you had fun there with interest in exponential equations.